Okay, so we're going to be talking about model context protocol here for the next probably 45 minutes or an hour, maybe less. How to use them and how to build them. Now, I don't have a lot of slides because it's actually a lot easier than something like retrieval augmented generation, but let's take a look. So I like to focus on the P in MCP, the impact of protocols, right? So think about mail and SMTP. Does anyone ever remember handwriting a letter and putting a stamp on an envelope? We don't do that very much anymore, right? Or visiting a website with a web browser, or other protocols like OSPF or BGP, right? The rise of the internet, the rise of client-server. Now, MCP is client and it's server, and I like to say it backwards. So what it is, it's a protocol, just like SMTP or HTTP, that provides context to the model. So if you say it backwards, it's pretty self-explanatory, and context is maybe the routing table, maybe a SQL query against the database, maybe an API call, could be almost anything. So we say it backwards, and I like to think of it as the USB-C of protocols. So when we have an agent, I can go MCP shopping and just plug in MCPs, like USB keys, into that agent. It's 18 months old. It's coming up on 2 years in November, and there's already 17,000 MCPs on mcp.so. All of the major players are behind it, including Cisco. Last week, Cisco introduced an MCP for NSO. NSO is a pretty complicated platform, but be able to talk to that in natural language is a really big step forward. The CCNP automation track includes MCP on there as well. And in terms of client server, it's kind of like DHCP in that the server is going to advertise its tools. So instead of advertising an IP address to a client in a pool of IPs, we've got a pool of tools that the client offers, or the server offers the client. So once I've plugged that USB in and my client has discovered those tools, now the agent can call those tools. So this is not the fanciest graphic, but the idea is that we can talk to local resources or resources over the web, over the internet, using MCP, right? So a mix might be the OpsMill InfraHub MCP, my PyATS MCP, maybe a Subnet calculator MCP or a ServiceNow MCP. So this, I think, really shows how easy it is to build an MCP. We do the import FastMCP from the package. We instantiate it as an object. We define and decorate tools. Now, this happens to be an asynchronous Python tool, but here could be SQL, REST API, whatever you want to decorate. Finally, we run the MCP server. This is likely going to be on that Cisco exam, how to instantiate and build a fast MCP. Now, there's many clients, including Claude Desktop, Claude Code, Gemini CLI, VS Code Copilot, agents that you build on your own. And I like to specifically call these agents React agents. And there's a paper on Arvix that introduces this idea of an agent that can reason and take action, and the action is in the form of calling tools. So that's why they developed the protocols, that agents had a standard way to invoke tools that they've been bound to, right? And they have agency to act without human intervention. You don't have to tell the agent, use this particular tool. It will use its reasoning to figure out the correct tool to call. If you want to maybe check this QR code out, I wrote a blog post called The Ultimate MCP Guide. As of the writing of this article, there was 56 infrastructure MCPs that I found. 56. Now, how many of those do you think were released by vendors? One. All of the other ones are from the community so far. Now, the NSO one is an official one, so I would say 2. Thousand Eyes has an official MCP server, which is pretty cool. We'll save some questions. I'm going to get into using and building MCP next with the real lab. And this presentation and all the code is available on this GitHub repository. So if you want to run these labs on your own at the end of the week, all the code is open source. I chose to use OpenAI as the LLM because it's fairly universal. But let's take a look here at Lab 1. So if we look at the actual server, all this is an MCP to multiply two numbers together. And I did that very on purpose to make it as easy as possible. It's 30 lines of code. You can see, just like the slide showed, we import FastMCP from the server. We instantiate it with a name. We decorate the tool. And then we have our Python logic. Now, I've written an agent to go along with this code. Now, this code is not as important. It's very bespoke code. You could write agents many, many different ways. But I want to show you that it's all based on JSON-RPC, JSON Remote Procedure Call 2.0. That's the transport mechanism. And you can see there's a method tools call. So this agent has a method to call the tool. So let me get the virtual environment going. Whoops, that's not what I wanted. Okay, so if I do lab 1 and I do Python 3 server, this just tests and proves that the server will run in standard input-output mode. So there's two different modes. There's streaming HTTPS for remote MCP, or there's local standard input-output. Okay, so the server's good. Let's try the agent. So now if I run agent.py, it's going to ask me for two numbers separated by a space. Let's do 5 and 10, and we get 50. And that's not the miraculous thing. It's just a hello world. But if we look at the next lab, this lab, the server is a subnet calculator. So import FastMCP, instantiate the server, and then here's my tool to calculate the subnet. And I have all of these different results that I want to pass back to the client. Now, can an LLM do subnetting on its own? Maybe. But why take the chance? Why use the non-deterministic? But this lets it reason and have an actual Python function based on the IP address library. So if I switch back into lab 2 and I run my server, you can see that it starts up fine. Okay, that's good. And now if I run the agent, I can feed it any seeder notation. Who started doing subnetting by hand with changing it from binary to decimal and all that? And then we graduated to what? Subnetcalculator.net or whatever, right? But it was full of viruses and worms and you had to be careful using it. But it was a nice, quick way to do subnet calculation. Check this out. So I'm going to let me do something huge. 10, 10, 90, 200/12. This model. All right, hang on. Huh. 12. Okay, here we go. It's calling the tool. The tool has calculated all of those functions, and now we're going to get the natural language response. So as you can see, here's the details: the network address, the broadcast, the net mask, the wildcard mask, number of addresses, usable hosts, first 10 hosts, seeder with net mask, seeder with host mask, and all of the properties of that IP address, subnet. So junior engineers don't just get a bunch of numbers, they get the human explanation around it. Now, the next one I'm going to do involves Cisco PyATS. So I have a testbed.yaml file that points to the DevNet sandbox, and I have my server here. This server is a little bit more involved though, okay? So I want to show you that they don't have to be simple little subnet calculators. They can be full-blown PyATS MCPs. So I have a bunch of classes. I have my get device, some helper functions for PyATS. But the further down we go, we're going to find those decorated tools towards the bottom. So there's our FastMCP instantiation. Here's the tool, asynchronously run the show command. Now this is known as a doc string, And the agent will read the doc string to know when to pick this tool, what this tool does, how it can be used. So if I switch over to lab 3 and we run the agent, let's just run the agent directly. So ask something. So I'm going to say, what can you tell me about the interfaces on device? And I'm going to get the host name of the device. Enter. Now the agent may decide, you can see the tools that it discovered, and now it's in the process of calling the show IP interface brief command using the show run command from the tools. And it's going to maybe gather a few different show commands and then give me a nice natural language answer about the status of the interfaces on this device. So it's trying a few different show commands. It successfully parsed all those commands with PyATS to JavaScript object notation. And now we should get a nice natural language description of the interfaces. If anyone wants to start with MCP, does anyone watch the Art of Network Engineering podcast with Andy? Andy Laptev and I showed him how to install Netbox's MCP in Microsoft Copilot and in Claude Desktop. It's only about an hour long. We left all the errors and all the problems in there in case you encounter the same issues. But here we go. So here we go in the natural language. Really cool. Okay, the device has active management routed interfaces, an active loopback, tunnel interface with a problem. So it actually will highlight that the tunnel interface is up, but the line protocol is down. All the switch ports are administratively down, means they're shut. Several VLAN interfaces exist, but none are fully up. Here's the interface details by tabular. Here's the switch port, junior engineer interpretation. So I could ask it anything I want. And one of my tools is, I believe I have a configuration tool. Let me just run this again and see what tools we discover.
Are you able to request it to respond in a specific format?
Please give me a table. Please give me a markdown file. Yes, you can. You can even say, go get the running config and give me a Jinja template of the config, right? So let's try that. I've got PyATS show run. So I've never done this. This is a high live wire act. Can you get the running config and provide me a Jinja to template I can reuse for other configs? Let's just try it. So ideally it calls the show run command. Oh, here we go, hang on. Oh, it needs the device name, of course. So learning configuration, successfully learned the config, and in a second or two, I should have a Jinja 2 template of that config, which then I could use to configure other devices in a standard way. So we'll give it a second, we'll give it some time.
So there's an API flash or everything.
These are the longest seconds, right? Waiting for the output. I know.
No, it's funny though, just like I didn't even think about how you return the formatting, because at first you think, why not just use APIs for everything
and get JSON back,
and
right?
JSON, get that. But it's like if you can actually get it in the format that's immediately users.
Well, I'm gonna give it a couple more seconds here. It hasn't crashed or anything. Come on, you can do it. Okay, so while that runs, I also have a fourth way to use consume. And here we go. So, yeah, look at it. It gave me this amazing Jinja template from the running config. And then even how to use it at the bottom, it shows you how you could convert it. Pretty cool. Okay, so let me show you the other thing. So now that I have these servers in these folders, if I go into the command palette of VS Code, and I go into the MCP open user config. Now let me just stop and type MCP. There's a lot of options here. You can even just say in browse for MCPs and install official MCPs that Microsoft advertises. But if you go into open user config, it will give you this JSON code. So what I've done here is there is the multiply two numbers, there's the subnet calculator, and there is the PyATS. And you can see that it has discovered 6 tools from PyATS. If I click on running, it brings you to the terminal console of that MCP server. So we've discovered 6 tools. Now we don't stop there. If I do Control-Command-I and bring up the Copilot, right? If I click on the little wrench here, there is my multiply two numbers. There's my netbox. There's my PyATS. So from here, let me get that host name again. I can say, can you please use the PyATS MCP to help me understand the routing table of device? Enter. Now, this may prompt me for permissions to use those tools. So it's reviewing the MCP, found the MCP server in the agent. Now I'll invoke the correct show command for the routing table. Allow the command. Yes, allow. No, I use the MCP.
Oh, yeah.
Should be using the MCP server. Hang on. No. Ha. Hang on a second. Let me turn off some of these other ones. Okay, so there's the routing table details through the MCP. So it ran the show command tool, it ran show IP route, and here's the human breakdown of all the routing tables. Now, let's try something fun and say, can you check that device for a Loopback 100? If it is not configured, please add Loopback 100 with an IP of 172.16.200.200/24 and enable the port. Enter. So we can actually do configuration management because one of those 6 tools that's been discovered is the configure device. So it should be going ahead and running that MCP tool to check for the presence of the loopback, and if it's not there, go ahead and provision it. So look, PyATS configure device, that's the tool, yes. And there's the interface with the IP and the no shutdown. You can say allow. It's going to go ahead and push that out to the device. And this was one of the shorter sessions because that really covers MCP. So if you want to go shopping for MCPs, again, we have that ultimate guide to the MCPs. Let me just give you a rough idea on what's out there. Itential Ultimate Guide MCP. 56 essential MCP servers for driving automation. And we break it all down into groups. So Itential, PyATS, F5, Catalyst Center, Cisco CML, Junos, Arista CVP, Container Lab, Cisco ACI, ICE, FMC, Meraki, Thousand Eyes, SD-WAN, Netbox, Autobot, InfraHub, ServiceNow, AWS, all kinds of AWS, Terraform, HashiCorp Vault, even more AWS, Grafana, Prometheus, Datadog, Dynatrace, New Relic, PagerDuty. CVEs are a good one. So what you can do is plug the PyATS MCP and the CVE MCP in and say, go get all my versions with PyATS and look up any vulnerabilities on CVE. Generate a markdown report, right? ICE has one that I wrote. GitHub has one. Microsoft Graphs, Wikipedia, RFC lookups. So if you're developing a solution and you want to use the actual RFC data, plug the RFC MCP into your agent. Help me develop an OSPF policy that adheres to RFC whatever. Or I'm using a diffserv policy. Go get RFC 4954 and help me write my diffserv policy. And then maybe use PyATS to push that diffserv policy out. Right? You can do all of this stuff through agents and through Copilot, and everything that I've shown you can also be done in Claude Desktop, for example. So thank you for joining me. This would have been lonely up here all by myself doing this to nobody. So thank you for joining me. Does anyone have any questions? Feel free, yeah.
Yeah. Do you have a recommendation on the number of active MCP tools to use without kind of bogging down your...
This is a brilliant question. The question is, how many tools can you use? Is there an upper limit? How do you pick and choose? So it is a real problem. Copilot has a soft limit of 80 tools, I think. Anywhere above 100 tools, and you know what starts to happen? The LLM hallucinates and starts picking the wrong tool for the job. So what you want are nice, tight agents with real limited scope, and you'd be better off having 3 or 4 small agents. This agent does your ServiceNow. This agent does your PyATS. This agent does your compliance. And you get the agents to work together, but each agent only has their own specialty, right?
As opposed to having like one network agent
that has everything. Yeah. Think of it as an org chart, as a people problem. How would I organize? If I were to hire 5 new network engineers, where would I put them? How would I use them? Would they answer to me? Would they report to security? Think of them as your own little junior assistants, right? And if you can have an agent to help you out in the day, how many circuits are free in Chicago? Let me ask my agent, right? That's like a half day of work doing it the old way, right?
So would you do that with something like OpenClaw or Vermes to write that down while you're on agents?
Yes.
Like you can still use Claude as your backend if you want it.
Exactly. And actually, speaking of OpenClaw, here on Wednesday at 3, I'm going to be covering my NetClaw project, which is OpenClaw mutated to be a network engineer. So I'm going to be covering that at 3 on Wednesday. And we're giving away a Mac Mini so you can run your own NetClaw. So make sure you get badged in and get in the draw. Any more questions? Keep them coming.
Yeah, I don't want to take...
No, please.
So is this something that only works really well with the frontier models, or do some of the open ones kind of work, well, if you don't have like a...
Right.
All I have is a man.
No, that's a great question. So the question is about, do I have to have a frontier model, a cloud model, a high-end paid model? No, but the open source model you choose has to be able to call tools. So that's the only thing, is that the open source model, like let's say Gemma 4 from Google, they just released it. It has the ability to call tools, and you can do everything you've seen today for free locally with Gemma. I'm going to be covering open source models tomorrow in one of my sessions on how to get started with OLLAMA and things like that. Yeah.